Welcome to the lesson on locus. This case is C2019, question number 19. It reads, the figure KLMN below is a scale drawing of a rectangular piece of land. Length KL is equals to 80 meters. Now for the purposes of explanation, I've enlarged my rectangle, so it is not exactly 80 meters. I've enlarged it for the purposes of easier demonstration as I teach it. So the figure is there, KL is given there. Now the questions are as follows. Part A, on the figure, construct the locus of a point P which is both equidistant from points L and M and from lines KL and LM. 3 marks. Part 2, the locus of a point Q such that angle KQL is equals to 90 degrees. Then part B of the question, part 1, show the region R bounded by the locus of Q and the locus of points equidistant from KL and LM. And the last one, find the area of the region R in meters squared. Take pi to be 3.142. So those are the questions. Now the diagram is here. You need a pair of compass, which I have here. You also need a ruler, sharp pencil, of course, and a rubber. Now let's go to the first part of the question, part 1, constructing the locus of a point P which is both equidistant from point L and M and from lines KL and LM. So we're going to begin with this part, the locus of a point equidistant from point L and M. So look at the diagram there. Point L is there and point M is there. So the locus of a point equidistant from two given points is obtained by joining the 2 points using a straight line and constructing the perpendicular bisector of that line. I repeat, the locus of a point equidistant from 2 given points or 2 fixed points is given by joining the 2 points using a straight line and then constructing the perpendicular bisector of that line. So in this case, point L and M, you need to construct a perpendicular bisector of that line. So to do that, simply take your pair of compass. You stand at L. You can make it longer. Then make sure that you open it more than the radius of that line, LM, and with that radius you can mark an arc there. You can mark an arc there. Then without adjusting in the radius, you can get rid of this ruler here. You can mark another arc there. Then you transfer these the same. Can transfer the same. Let me adjust these. Yeah. You stand at point. You stand there at M. So with the same radius without changing the arc that you made, cut that arc. Then you proceed and cut the other arc. So after doing that, take your ruler. There is the ruler. Then join the two points of intersection of the 2 arcs using a straight line, and that is simply how you're supposed to construct the locus of a point equidistant from points L and M, simply perpendicular bisector of that line. Now the next question is now there are two locus that you're sublocalized that you're supposed to construct in that question. The other one is the locus of a point equidistant from lines KL and LM. Lines KL and LM. Look at them. Lines KL and LM. So note this, that the locus of a point equidistant from two given lines is given by constructing the angle bisector between the two sides or between the two lines. So that is how we get it. Constructing the angle bisector between the two sides. So in this case, the angle between KL and LM is angle KLM, and that is what we need to construct. We construct the bisector of that. To construct the bisector of that, what you need to do is simply to take your pair of compass. Take your pair of compass, then stand at that point where you have the angle you want to bisect. I can make this one to be a little bit smaller. So then from there you can mark an arc on this line, then with the same radius, without changing the radius, you mark an arc there. Then now you can adjust this size. So you stand on this arc, you stand on that arc. I want to make this one to be a little bit longer. Yeah, then I can use different color there. So standing there, you can mark an arc there, and then you can transfer to the other arc. Transfer to the other arc that you made. Stand there, then cut that arc. So I have to go back because I had not made a longer one. So I have to ensure you make a longer arc. So that is the arc. That's good. Now after making that arc, now you can join the point of intersection of that arc and to bisect that angle. So that is the point of intersection. So there it is. Then using a straight line, that is the angle bisector. That is how you simply require to do that. So now we have constructed the two locus, the locus of a point equidistant from K and L, and K and L and M, that is the angle bisector, and the other one was the locus of a point equidistant from two given points, that is L and M. Now let's proceed to the next question. So the locus of a point, so we need to indicate the point of intersection of those two lines, that is where we have point P. So P is here, so P is somewhere here. So P is exactly here in the middle, so that is where we have P. So P is this point of intersection of those two lines. The next thing you're going to do, let's go to the next question. The locus of a point Q such that angle KQL is equals to 90 degrees. KQL is equals to 90 degrees. So look at K and L, where K and L is. So we need to get a certain angle KQ. Q should be above that line KL, such that the angle that will be formed will be 90 degrees. So there is one property that you need to recall in this part of a question. KL will act as the diameter, so we need to locate the center such that the angle that you're going to make at the circumference will be connected to the property, the diameter, the angle the diameter makes with the circumference, that is 90 degrees. So what you're going to do in this case, you shall locate the center of that circle, will be between K and L. So we need to obtain the center there. So obtaining the center, we need to construct the bisector of KL. Bisector of KL. So stand at K, and then since we want to bisect, you open it more than half of that line. This is what you do. Make it a bit longer. Then from here you can mark an arc. There will be too many arcs here, so you need to be careful not to get confused of the arcs. So you can transfer the same measurement without adjusting. We are bisecting, obtaining the center of KL. So note the arc that we made, so cut that arc. So once you've done that, now this one is just to help us locate the center, just locating the center. So taking your ruler, this one is just to help us locate the center, nothing else. And to get the center, I needed to do something else here. So let me do this. Let me repeat that step once again. I have to delete those arcs that I've made and do it afresh. This is something that I've noticed. So to obtain the center, this is what you need to do. We need to construct the bisector of KL, and this is how we do it. There are several arcs that I've not made there. So you stand here at K, at L, then you first get rid of these. And my space will be enough here. So I will need to redo it again. So standing there, open it more than radius. I have to change the color here. then mark an arc there. Have to move up here because of space. Then with the same radius, I mark an arc there. Then I transform. Then the arc that I've made, I need to cut that arc there, and then the one that is below here, I cut it there. So looking at it now, I'll be able to obtain the center, of that line KL. So this is just to help me get the center, and the center will simply be, you will look at the intersection of that, so that will be the center. So having that at the center, having that now as the center, to draw, I will use this one as the radius. So I'll use this one as the radius. This will now be the radius. That will be the radius. Then the arc that the circle that I'm going to make here, we use a different color here, different thickness. So if you draw the circle, that is a circle, that locus, you can see it is forming a circle. So any angle that you form on that arc, K, Q, L, so Q lies anywhere on that arc that I've drawn, the whole of this arc that I'm making here. And I want to make it little big. This one, I think I should use a different pen so that it can be visible. Yeah, this one is better, I think. So there it is. So any point that lies on that arc that I'm making is where Q lies, and that will give 90. Any angle that makes that arc makes with the line KL, it will be 90. Recall that property of the diameter of a circle and the radius and the circumference. The diameter makes 90 degrees with the circumference. At any point that you take, makes 90 degrees. So Q is anywhere on that arc. Now, having done that, we are almost through. Having done that, Q is therefore any point along that. So Q is anywhere along this arc, and then sorry, let me delete this. And point P is here. We had identified that. So P is here. That is where point P is. Now, having obtained that, think now we're in a position to go to the next question. And the next question, you're supposed to shade the region R bounded by the locus of Q and the locus of points equidistant from K and L, KL and LM. Now the locus of a point equidistant from KL and LM was the angle bisector of angle KLM. You can see that line, you can see where they're intersecting. And then the locus of Q is that arc. So the region that we require, is this region that is here. This is the region that we require. It is bounded by locus Q, and then the locus of a point equidistant from KL and LM. That is the angle bisector. You can see that line that is intersecting at P. So that is how you obtain it. After identifying the region, that is 1 mark, find the area of the region R in meters cube, in meters squared. Now when you look at that region, we simply need to do something here. There is this line, which was a very crucial one that we need to draw. This line that is this point of intersection here. So I need to, this point of intersection here is what I'm looking for. There's that point that is there. So I've made quite a thicker line for easier visibility. So when you look at that point of intersection of this P, of course we need to now get the area of the shaded region. That is a sector, and there's something that you notice here, that this point that is here, this angle is 90 degrees. That angle is 90 degrees. So to get the area, you can see the shaded region is forming a sector. So this is the radius and this is the radius, and the area of the shaded region will be obtained by getting the area of the sector, and then we subtract the area of that triangle that is here. So we simply need to take the measurement of this radius, and since I've not used the exact measurement, the measurement that I've used are not exact unless I measure. You'll need to get the area of the shaded region. Just have to demonstrate it here. Let me rub this. So the area, the shaded region, so shaded region is given by area of the sector minus area of the triangle. In this case, rub this. In this case, the radius is there. You just take the measurement, and having known that this angle is 90, the angle that this one makes, this is 90 degrees. That is 90 degrees. So if you want to get the exact measurements, I have tampered with the measurements of that a rectangle because I've enlarged it. So unless I measure and this one, the area of the sector, I'll just give a demonstration of how you're supposed to do it. So the area of the sector, something is wrong here. Let me rub these. So the area of the sector is simply, what you need to know is the formula. This is the most important thing that you need to know. Is given by theta over 360 times pi r squared. That is how you get the area of the sector. Then the area of that triangle, you simply get it by a half base times height, or you can simply use a half AB sine theta. So this is what is going to give you the answer. I think once I have demonstrated on how to construct the different loci, getting the area will not be challenging to you. So let me go up to the diagram. So you just need to substitute. See the angle at the center there to get the whole of that sector is 90 degrees, and then you just take the measurement of the radius, and that will give you the area of the whole sector. So to remain with the shaded region, you just need to subtract this triangle, and that will give you the answer. That is simply how you're supposed to work out that question on loci. Thank you.